Welcome back to the podcast. Today, we're diving into the intriguing world of distributed databases, building on the foundational concepts we've discussed in previous episodes. We'll explore the complexities of data systems and large applications, the significance of integrating multiple data stores, and how different processing styles can influence performance. So, grab your headphones and let's get started. In our earlier discussions, we laid the groundwork for understanding distributed databases, covering everything from data layout on disk to the limits of consistency when faults occur. However, we made one key assumption that there was only one database involved. In reality, applications are rarely that straightforward. In large applications, data needs can be quite diverse, often requiring more than just a single database. Developers frequently turn to a combination of various data stores, indexes, caches, and analytics systems. This multifaceted approach allows for optimized access patterns tailored to different needs. The challenge, however, lies in integrating these disparate systems into a cohesive architecture. It's a crucial aspect of system building that vendors sometimes overlook when they claim their product can handle everything. When we discuss data in these systems, it's important to distinguish between two categories, the system of record and derived data systems. The system of record is where new data is first written, ensuring that each fact is represented exactly once. This serves as the authoritative source of truth. Derived data, on the other hand, is often redundant and can be recreated from the original source. Think of caches or materialized views. These are derived from the system of record to boost performance, especially for read queries. Understanding this distinction brings clarity to what can often be a confusing system architecture. It helps clarify the data flow through your system, making explicit which parts have which inputs and outputs. This isn't just about the tools themselves. It's about how you use them in your application. Now, let's shift gears and talk about how data is processed. There are three primary styles to consider. First, we have online systems, which are services that wait for requests from clients. When a request comes in, the service processes it and sends a response back. Response time is crucial here, as users expect quick results. Next, there are batch processing systems. Unlike online systems, batch processing takes large amounts of data, processes it, and produces output without requiring immediate user interaction. This method is often scheduled to run periodically, and its effectiveness is measured by throughput. Then, we have stream processing systems, which sit between online and batch processing. Stream processing handles events shortly after they occur, allowing for lower latency compared to batch systems. This real-time approach is becoming increasingly important in today's fast-paced data environments. Batch processing isn't a new concept. It has historical roots that go back to punch card tabulating machines. One significant advancement in this area was the introduction of MapReduce, a programming model that revolutionized batch processing on commodity hardware. While its prominence may have waned, understanding MapReduce is essential as it illustrates the principles of batch processing and sets the stage for modern data systems. Let's ground our discussion with a practical example. Imagine you have a web server that logs every request it serves. You can use Unix tools to analyze this data quickly. For instance, with a simple command line pipeline, you can extract the most popular pages from your access logs. This process highlights the power of Unix tools, which can efficiently and flexibly handle large data sets. If you prefer coding, you can achieve the same results using a programming language like Ruby. By reading the log file and counting the occurrences of each URL, you can easily identify the top pages. This illustrates how both command line tools and programming languages can be effectively used for data analysis. As we wrap up today's episode, Remember that building a successful distributed database system involves understanding the complexities of your data needs and how different systems interact. By distinguishing between systems of record and derived data, and recognizing the various processing styles, you can create a more efficient and scalable architecture. Thanks for tuning in. If you enjoyed today's discussion, be sure to subscribe for more insights into the world of data systems. Until next time, keep exploring and questioning the fascinating landscape of technology.